Welcome back, everyone. Let's dive right into this explainer and completely demystify Florida real estate math. We aren't just going to sit here and memorize formulas today. Instead, we're essentially going to build a residential neighborhood from scratch using the exact same mathematics that developers, appraisers, and exam writers use every single day. Here's our exact blueprint for today's session: area and acreage conversions, calculating maximum lot yield, setbacks and buildable area, and finally, a Florida math pop quiz.
Section 1. Area and acreage conversions, the foundation.
We've got to start at the macro level, which means getting incredibly comfortable with how we measure raw land. Go ahead and cement this golden number into your brain right now: 43,560. There are exactly 43,560 square feet in a single acre. Whether you're dealing with a tiny suburban lot or a massive agricultural tract, this conversion factor literally unlocks everything else we're going to do today. And this right here brilliantly illustrates why this actually matters. These aren't just abstract numbers floating around in a textbook. Converting square footage to acreage correctly is the literal foundation of property tax assessments, capitalization rates, and allocation appraisal documents. A single mathematical error here cascades into thousands of dollars of mispriced real estate, and nobody wants that. Now, here's the first major trap to watch out for. Area questions are pure arithmetic, but the mistake almost always happens when you reverse the operation. If you accidentally multiply instead of dividing your square footage by 43,560, your answer is going to be wildly outside any reasonable range. Look, if your calculator suddenly tells you a standard lot is 2 billion acres, yeah, that's your immediate cue to hit clear, reverse course, and divide instead. Section 2. Calculating maximum lot yield, subdividing the land. Let's move to our second phase and see how this all builds together. Imagine taking a large multi-acre parcel of raw land and mathematically chopping it up into a residential subdivision. But before we can build a single house, we absolutely must define net usable acreage. When developers buy land, they can't actually use all of it for houses. Local counties require them to dedicate a percentage of that land to public infrastructure. Think streets, sidewalks, utility easements, and stormwater management ponds. You have to subtract that unbuildable space first to find your actual net usable land. So the crucial point here is following these sequential steps. Let's look at a 15-acre raw parcel where the county mandates a 25% infrastructure dedication and zoning requires a minimum lot size of 8,000 square feet. Step 1, multiply those 15 acres by 43,560 to find your gross square footage. That's 653,400. Step 2, subtract your 25% county street dedication, which leaves you with 490,050 net usable square feet. And finally, step 3, divide that net area by your 8,000 square foot minimum lot size. That gives us 61.256 lots. Now, what's really interesting is how easily you can get tricked if you ignore real-world logic. Notice that crossed-out cluster of homes? The 81-lot trap happens if you just divide the gross acreage directly by 8,000, completely forgetting that roads actually have to exist. Then there's the 62-lot trap, which catches folks who think they should round up mathematically. But remember our golden rule: you cannot physically round up a fractional piece of land into a whole house. You always round down to the nearest whole lot. Section 3. Setbacks and buildable area, the house scale. Now that we've successfully subdivided our neighborhood, let's zoom in on a single lot and figure out exactly how big of a house we can fit on it. To find our maximum buildable area, we first have to respect setbacks. These are the invisible, mandatory boundaries imposed by local zoning ordinances that literally push your house away from your neighbors and the street. They ensure light, ventilation, fire safety, and, keep your neighbor's loud pool pump at a reasonable distance. Let's work through this detailed scenario together. Say we have a lot that's 110 feet wide by 150 feet deep. The local rules require a 25-foot front setback, a 20-foot rear setback, and 10-foot side setbacks. First, calculate the buildable width. Take the 110-foot total width and subtract both the left and right side setbacks. So, minus 20 feet, leaving you with 90 feet. Next, calculate buildable depth. Take the 150-foot depth and subtract the 25-foot front and 20-foot rear setbacks. Minus 45 feet, leaving 105 feet. Finally, multiply your remaining dimensions. 90 by 105 gives you a maximum buildable footprint of exactly 9,450 square feet. And here is the absolute most common trap you will see on an exam or out in the field. People frequently subtract a side setback only once. They'll take the 110-foot width, subtract just 10 feet, and use 100 feet for their width. Look, you must never forget that a house has both a left and a right side. Subtracting only once artificially inflates your footprint to 10,500 square feet, and I guarantee you that wrong answer will be waiting to trip you up on a multiple-choice test. Section 4. Florida Math Pop Quiz. Okay, time to put on your math coach hats. We've built the foundation, so now let's test your active recall with a rapid-fire 4-question pop quiz to see if you can dodge the traps we just covered. Question 1 tests our macro foundation. If a rectangular lot is 200 feet wide and 350 feet deep, what is its size expressed in acreage? Think back to your golden number. Did you remember it? First, you multiply 200 by 350 to get a total of 70,000 square feet. Then, you just divide that total by 43,560, giving you exactly 1.607 acres. Moving on, question 2 is a highly practical real-world comparison. Between these two homes, Home A at 2,200 square feet for $396,000 and Home B at 2,400 square feet for $460,800, which one actually offers the better value per square foot? Looking at the numbers here, a higher total overall price doesn't automatically mean a higher cost per square foot, even though a lot of people just assume it does. When you divide the total price by the square footage, Home A comes in at $180 a foot and Home B is $192 a foot. So Home A is indeed the cheaper property by $12 a foot. It's always worth doing the math. Question 3 is our blueprint challenge. Try to visualize this 90 by 120 foot lot. You need to apply a 25-foot front setback, a 35-foot rear setback, and 15-foot side setbacks. What's the maximum buildable area? And watch out for that trap we talked about. If you successfully avoided the side setback trap, seriously, give yourself a massive pat on the back. You correctly subtracted 30 feet from the width. That's 15 for the left, 15 for the right, leaving a 60-foot buildable width. Then you subtracted a total of 60 feet from the depth, 25 for the front, 35 for the rear, leaving a 60-foot depth. 60 multiplied by 60 leaves us with a perfect 3,600 square foot buildable footprint. All right, final question, and it's a conceptual one about how real-world developers actually have to operate when the math gives them a fraction. If a residential developer calculates a raw lot yield of 61.256 lots after deducting required infrastructure, what is the final allowable lot yield? Basically, what do you do with 61.256 lots? The answer is exactly 61 lots, because no matter what your calculator says and no matter how standard rounding rules work in your high school algebra class, you can never mathematically manifest enough land to build a family home on a quarter of a lot. Fractional lots are always discarded. And that brings us to our final takeaway. As you master these formulas, ask yourself this: how might these strict setback rules and massive infrastructure deductions inadvertently be causing the housing shortages or suburban sprawl we see today? Real estate math isn't just numbers on a page. It's the invisible, rigid blueprint that dictates the physical reality of the world we drive through every single day. Look a little closer at your own neighborhood, and you might just see this invisible math at work. Thanks for joining me on this explainer, and I'll see you next time.